Assalamu alaikum, my name is Mohammed Awais Rashad, and this is my final presentation for task 7.1 of the Arch Technologies Machine Learning Internship. In this project, I've implemented brain tumor segmentation using two powerful AI models, YOLOv11 for detection and SAM2 for segmentation. We begin with data preparation. I collected a custom brain tumor dataset from RoboFlow, which includes images of meningioma, glioma, and pituitary tumors. The dataset is formatted in YOLO structure with separate folders for training, validation, and testing, along with a data.yaml configuration file. Next, I trained the YOLOv11 model using Ultralytics Python API. During training, I monitored model performance through visual metrics like the loss curve, F1 score graph, and the confusion matrix. The results were saved in the runs detect train directory. Once training was complete, I moved on to testing and inference. I loaded the best model weights and passed a test image through it. YOLO successfully drew bounding boxes around the detected tumor region. These detections were stored in runs/detect/predict, showing accurate tumor localization. To improve granularity, I introduced SAM2 model using the bounding boxes generated by YOLO. I passed the original image and detection coordinates into the SAM2 model. This resulted in precise segmentation masks that highlight the exact tumor boundaries inside the image. For example, in the image named pituitary_5.jpg, the model first detected the region with YOLO and then segmented the area accurately. All relevant files have been organized and uploaded to my GitHub repository. This project gave me hands-on experience with object detection and segmentation and helped me understand how to combine multiple models for advanced computer vision tasks. Thank you for watching. I hope you found it informative.